Hello, my name is Maria Paz Chidichimo. I am a physical oceanographer and I am based in Buenos Aires in Argentina. Thank you very much for having me here. Today I will be talking about ocean circulation in the South Atlantic, and this is part of the work that we are doing with iAtlantic. Just to briefly introduce the importance of the South Atlantic Ocean, we can see on this schematic that belongs to a recent review article on South Atlantic circulation and water mass changes that we recently published in Communications, Earth and Environment. We can see the main flow pathways that come from the Atlantic Meridional Overturning Circulation, the AMOC, in the entire Atlantic Basin. So the red colors represent the surface flows, the yellow represents the intermediate flows, and the blue and the purple are the deep and abyssal flows. So the South Atlantic is the only basin with an equatorial heat transport. It connects the AMOC with the other ocean basins, as we can appreciate in this schematic. Also, the freshwater transport exiting the South Atlantic is thought to have an influence on AMOC stability. In terms of observations of volume, heat, and salt transports in the South Atlantic, one of the main arrays is the Samba array at 34.5 south, which is between South America and South Africa, and which has been established in 2009, and in particular in the Southwest Atlantic, the array is termed Samba West, and we can see the southward flowing Brazil current here, and the intermediate flows, and the deep western boundary current below, and abyssal flows below. And where the southward flowing Brazil current encounters the northward flowing Malvinas current, it conforms the Brazil-Malvinas confluence here, which is one of the most energetic regions of the global ocean. And this is a collaboration between the US, Brazil, and Argentina, and with collaborators from different countries in recent years. And we are, of course, interested in long-term changes in the South Atlantic, which are the possible regional and global impacts. So we look into temperature and salinity trends in the upper ocean, which here is defined between the surface and 700 meters, and in the intermediate levels between 700 and 1,000 meters. So we can see from the temperature trends, which are here in the upper panels, that the warming is occupying the entire domain of the South Atlantic, while for salinity, the upper ocean is gaining salinity, and at intermediate levels, most of the South Atlantic is freshening. And from bottom in situ temperature, from measurements here at the Samba West array, from instruments deployed by NOAA AOML, we also observe a long-term warming trend at both sides, at the deepest side at 4,500 meters and 4,700 meters roughly. And what is also important, if we look into the Southwest South Atlantic here, is that these changes are more prominent in this region. So we see an upper ocean warming of 1.2 centigrades per decade, and a maximum salinity increase of 0.15 PSU per decade, following the path of the Brazil current and in the Brazil-Malvinas confluence. And in the context of the projected AMOC weakening, which is predicted by climate models, additional surface southern hemisphere warming is expected, and this will also, of course, affect the South Atlantic. So it's really important to keep monitoring and understanding these changes. In terms of daily records of volume transports, we have derived a multi-year daily record of the Brazil current, mainly using pressure recording inverted echo sounders, which are termed PIAS, which are funded by NOAA AOML in the US, which are the black triangles here, and CPIs, which are current and pressure recording inverted echo sounders, which are funded by the University of Sao Paulo in Brazil, which are the yellow circles here. So from these measurements, we have derived a multi-year record of absolute Brazil volume transport, Brazil current volume transport, and what we can see is that there is a large high frequency variability. So the changes occur in very short periods, and we didn't find significant seasonal cycle interlinear variability or trends, and 80% of the variance is concentrated at periods less than 150 days. So this points to the need of continuing measuring for longer periods of time and update to a 13-year long Brazil current record, which will expand between 2009 and 2022, is in preparation. So based on these results and this analysis, we have proposed to deploy a toll mooring within iAtlantic in this region here at the 700-meter isobat to sample at the core of the Brazil current in a continuous manner throughout the entire water column, temperature, salinity, ocean currents, dissolved oxygen. So this toll mooring has been deployed in December 2022. And this work was done in collaboration with the sister project Triatlas, which was also funded by the same EU call. So the iAtlantic mooring sits, as I said, at the 700 meters here, and it's measuring temperature, salinity, velocity, and dissolved oxygen. And the Triatlas mooring is deployed at the 3,400-meter isobat, and is led by Germany, and it's measuring temperature, salinity, and velocity throughout the entire water column. So this is really important because this really allows to enhance the monitoring capacities in the South Atlantic to measure essential water properties and ocean currents throughout the water column. And these observations provide crucial information on how these properties change over time and how they influence ecosystem changes and marine resources, in particular in a region where this type of observations are quite scarce or simply do not exist. So far, we did not have collocated measurements, time series measurements of temperature, salinity, velocity, and dissolved oxygen. So to sum up, as a result of the excess heat absorbed from the atmosphere associated with ongoing planetary warming, AMOC variability, interocean exchanges from the Pacific and the Indian basins, and climate change, the South Atlantic Ocean has warmed from the surface to the deep and abyssal ocean. The upper ocean South Atlantic salinity has increased, and intermediate deep and abyssal waters are freshening. And in particular, for the upper South Atlantic, these changes are very much more prominent than for the rest of the basin. So we see pronounced warming, and we see pronounced salinification, and also we see warming at the intermediate and deepest layers. So continuing to observe the temporal evolution of meridional volume, heat transports, and salt transports in the Southwest Atlantic, their water mass changes, their causes, and their large scale and regional impacts on heat content, sea level, extreme weather and climate, ecosystem, fisheries is important. The new iAtlantic toll mooring deployed in the Brazil current to enhance monitoring capacities in the Southwest Atlantic is crucial. This mooring is a significant addition to the existing observations in the subtropical South Atlantic and provide for the first time in tandem time series observations of mid-depth dissolved oxygen, velocity, temperature, and salinity. And this will allow to study collocated changes in ocean currents and water mass properties, which are relevant to marine ecosystems. And this will be also an important contribution to regional assessments, but also to produce more robust global assessments. Thank you very much.